Chemistry Workbook for Dummies. Introduction. The first essential in chemistry is that you should perform practical work and conduct experiments, for he who performs no practical work nor makes experiments will never attain the least degree of mastery. One of the wonders of this word is that objects so small can have such consequences. A deep, visible lump of matter, even a mere speck, contains more atoms than there are stars in our galaxy. Chemistry is at once practical and wondrous, humble and majestic, and for someone studying it for the first time, chemistry can be tricky. That's why we wrote this book. Chemistry is wondrous. Workbooks are practical. This is a chemistry workbook. About this book. When you're fixed in the biggest of stoichiometry or bogged down by buffered solutions, you've got little use for rapturous poetry about the atomic splendor of the universe. What you need is a little practice, a little practical assistance. Subject by subject, problem by problem, this book extends to pull you out of the thickest and bogs. The topics covered in this book are those most often covered in the first course of chemistry. The focus is on problems like those you may encounter in homework or on exams. We give you just enough theory to grasp the principle at work in the problems. Then we tackle example problems. When we tackle practical problems, this workbook is modular. You can pick and choose those chapters and types of problems that challenge you most. You don't have to read this book to cover it if you don't want to. If certain topics require you to know other topics in advance, we tell you so and point you in the right direction. Most importantly, worked out solutions and explanations are provided for every problem. Conventions used in this book. We provide the following conventions to guide you through this book. Italic highlight definitions, emphasis, certain words and points about variables and formulas. Boldface text points out keywords in bulleted lists and actions to take in numbered lists. Foolish assumptions. We assume you have a basic facility with algebra and arithmetic. You should know how to solve simple equations for an unknown variable. You should know how to work with exponents and logarithms. That's about it for the math. At no point do we ask you to say considered and contradictions between the Schrödinger equation and stochastic wave function collapse. We assume you're a high school or college student and have access to a secondary school level or higher textbook in chemistry or some other basic primer, such as Chemistry for Dummies, written by John T. Moore, EDD, and published by Wiley. We present enough theory in this workbook for you to tackle the problems, but you'll benefit from a broader description of basic chemical concepts. That way you'll more clearly understand how the various pieces of chemistry operate within a larger whole. You'll see the compound for the elements, so to speak. We assume you don't like to waste time, neither do we. Chemists in general aren't too fond of time wasting, so you're impatient for progress. You're already part chemist at heart. How this book is organized. This book is divided into thematic parts. By no means is it absolutely necessary to consume all chapters of a part in sequence, nor is it necessary to process in a straight line from one part to the next. But it may be useful to do so, especially if your starting place is of total chemistry bewilderment, TCB. Part 1, Getting Crazy with Numbers. Chemists are part of a larger scientific enterprise, so they handle numbers with care and according to certain rules. The reason for this meticulousness becomes clear as you consider the kinds of measurements chemists routinely make on very large numbers of particles. The most familiar of these kind of chemical particles are atoms. This part covers some must-know materials about numbers in chemistry, describes the basic structure of atoms, outlines how atoms belong to one or another variety of elements, and explains how atoms interact with different states of matter. Part 11, Making and Remaking Compounds. Reactions are the dramatic deeds of chemistry. By reacting, atoms assemble into compounds, and compounds transform into other compounds. This part gives you the basic tools to describe the drama. We explain the basics of bonding and the system of naming compounds. We introduce you to the mole, to chemical equations, and to stoichiometry, simple concepts you'll use for the remainder of your chemical career, however long or brief. Part I. Changes in terms of energy. Chemistry is change. Change either happens or it doesn't. When it happens, change can occur rapidly or slowly, busy and industrious as they are. Chemists want to know whether the chemistry will happen and for how long. This part describes the kind of changes that can occur in chemical systems and the kind of system. I say solutions, in which those changes occur. We cover the different relationships between equilibrium. Will it happen? And the rate. How long will it happen? Will take time. And take the two to difference in energy between states, because chemistry transforms energies as well as matter. We explore some important ways chemists describe the changes in energy that drive chemical reactions. Part IV. Swapping charges. Charge is a big deal in chemistry. Charged particles are marquee players on the chemical playing field, and this part examines their playbook in great detail. Acid-base reactions are vital chemical events that include the actions of charged particles, such as hydrogen and hydrogen ions, H and OH. You'll see oxidation, reduction, or redox reactions are another critical class of reaction that include transfer of electrons, the tiny negatively charged particles that get both of chemical actions. Finally, we summarize nuclear chemistry, the special branch of chemistry that includes transformations of particles within the nucleus and positively charged part of an atom. Part B, going organic. Because most practicing chemists are alive, it should come as no surprise that many of them are interested in the chemistry of life. The chemistry performed by living things is largely organic chemistry, or the chemistry of multi-carbon compounds. Although organic chemistry is a central feature of living organisms, it's not limited to them. The energy of the materials industries, for example, are chock full of organic chemistry. This part provides a concise overview of organic chemistry basics, highlighting simple structures and the structural motifs and surveying of some important classes of organic molecules in biology. Part VI. The part of tins. It's easy to get lost into the science that covers everything from subatomic particles to cellular phone batteries to atomic spectra, from different distant stars. When you grow busy with TCB, plant your feet on solid ground in the part of tins. This part is reassuringly sufficient and practical, filled with the equations you need and helpful reminders about tricky details. Time spent in the part of the tins is never wasted. Icons used in this book. You'll find a selection of helpful icons nicely nested along the margin of this workbook. Think of them as landmarks, familiar sign points to guide you as you cruise through the highway of chemistry. Remember, within every pithy summarized chemical concept passage marked by this icon represents the pithiest must-know bit of information. You'll need to know this stuff to solve problems. Sometimes there's an easy way and a hard way. This icon alerts you to passage intended to highlight an easier way. It's worth your while to linger for a moment. You may find yourself nodding quietly as you jot down a grateful note or two. Warning, chemistry may be a practical science, but it also has pitfalls. This icon raises a red flag to direct your attention to easily made arrows or other tricky items. Pay attention to this material to save yourself from needless frustration. Example, within each section of a chapter is an icon announces, here's ends theory, and let the practice begin. Alongside the icon is an example problem that employs the very concept covered in that section. An answer and explanation accompanying each practice problem. Here we go. Where we go from here. Where you go from here depends on your solution, your learning style, and your overall state of DBC. If you're currently enrolling in a chemistry course, you may want to scan the table of contents to determine what material you've already covered in class. You recall any concepts that could